take us into rhumb line sailings. There are basically three sailings which fall under the rhumb line sailing topic. That is the parallel sailing, the plain sailing, and the Mercator sailing. So we are going to see all these sailings one by one. We will understand what these sailings are and how can we use these sailings to find out the various parameters or things or values which we require. We will also see the formula connected to all these sailings and how those formula are applied. Now, before we go into these sailings, the first concept to be clarified in the mind is what is a rhumb line? We call all these three sailings, which we just now saw, parallel sailing, plain sailing, and Mercator sailing, as rhumb line sailings. So what is a rhumb line? A rhumb line is a line which cuts all the meridians at the same angle. So basically, a rhumb line will appear as a straight line on a Mercator chart. On a Mercator chart, all the meridians are parallel to each other. And since the rhumb line cuts all the meridians at the same angle, it appears as a straight line on the Mercator chart. It provides us a very easy method to calculate our courses and distances by using different mathematical formulas. So that's why we use these rhumb line sailings as our usual form of sailing. Unless the distances are very, very large, wherein we switch over to great circle sailing or composite sailing, for all the small handy distances, we use the rhumb line sailings. Rhumb line sailings do not give us the shortest distance on the surface of Earth. But what they provide is the simplicity, the ease of calculation, and the speed with which the answers can be obtained. So these are very easy and quick methods to calculate various courses and distances and to prepare our passage plan quickly. So that is the advantage of a rhumb line sailing. So let us go into these sailings one by one. Now the most basic form of rhumb line sailing is parallel sailing. Another concept which I would like to strengthen before we go into it is what do we mean by sailing? I have just now discussed with you 5 types of sailings. I will repeat that once again. First 3 were the rhumb line sailings, that is parallel sailing. Number 2, plain sailing. Number 3, Mercator sailing. And the remaining 2 are great circle sailing, that's number 4, and composite sailing, that's number 5. So what are these sailings? In the olden days, sailing was used only for ships which used to have sails. So whenever the ship was moving with the help of wind, we used to say that the vessel is sailing. But now the meaning of the word sailing is basically a method, a technique with which we can find out the courses and distances between any 2 points on the surface of Earth. You see, for a navigator, the basic and the most important thing to take the ship from one point to another point on the Earth's surface is that he should be able to prepare a passage plan. Now, for preparing a passage plan, for preparing or charting out a passage from the departure port to the next destination, we need to know the courses and the distances which are to be followed. We don't have any roads in the oceans, so we need to know what is the course which we need to follow and what is the distance which we need to steam. Once we know these two things, that is the course to be steered and the distance to be steamed, we are all set to proceed toward our destination. So that is the most basic calculation which a navigator should know. And sailings are basically different techniques with which we can obtain the courses and distances. Whether it is parallel sailing or plain sailing or Mercator sailing, or for that matter, great circle sailing and composite sailing, all these methods, they tell us what are the courses to be steered and what are the distances to be steamed to reach our destination. Now, as I briefly told you, the main difference between rumbline sailings and great circle sailing, the advantage of rumbline sailing is its simplicity and ease with which the courses can be calculated. We just need a simple scientific calculator and we should be able to solve for courses and distances. The great circle sailing and composite sailing is complicated compared to the rumbline sailings. But the advantage of GC sailing and composite sailing is they give us much shorter distances. And this becomes a very, very important point when you are going on a long passage. Say, for example, a transocean passage. So in this presentation, we are going to see the rumbline forms of sailing, starting off with parallel sailing, then going to plain sailing, and going to Mercator sailing. Now, coming back to the parallel sailing, as you can see clear from its name, we are traveling parallel to something. What is that something? We are moving along the parallel of a latitude, or we are moving parallel to the equator. So whenever the ship is moving parallel to the equator or moving on a parallel of latitude, this form of sailing is known as parallel sailing. Now in parallel sailing, the course of the ship need not be calculated. Depending upon in which the direction the ship is proceeding, the course will either be 090 if you are moving easterly, or the course will be 270 if you are moving westerly. So the course is very well known as you find the direction towards which you are proceeding. And for calculating the distance, we use the parallel sailing formula. What is the parallel sailing formula? It is departure equal to d long multiplied by cos of m lat. M lat stands for the mean latitude. This formula is used in parallel sailing as well as in the plain sailing. So for parallel sailing, the mean latitude is going to be the same as initial and final latitude. Both latitudes are the same. For plain sailing, when we use this formula, we take a mean of the latitudes of initial and final positions. That is why the term M lat or mean lat. This formula can also be remembered as departure upon d long equal to cos of m lat. So which way you are comfortable with. Now this departure is the east-west distance between the two places on the surface of Earth. So when you are on a parallel sailing, moving along the parallel of a latitude, departure gives you the total distance to be covered. So to find out the distance to be covered, you calculate the departure using the d long. D long is the difference of longitude between the initial position and the final position multiplied by cos of mean lat. So this is the only formula which we have in parallel sailing. As I told you, the course is already known as you know the direction in which you are proceeding. The direction can be immediately judged from your starting position and the destination. Looking at the two longitudes, you will be easily able to find out whether you are moving in the easterly direction or westerly direction. And the distance is found as departure using this formula. So this is the only parallel sailing formula.
Sir, sir,
बोलो बेटा, बोलो बेटा।
सर ये कह रहा था कि सर यहाँ पे जब ये कॉस ऑफ मीन लेटीट्यूड आ रहा है, इसका मतलब सर लेटीट्यूड डिफरेंट है थोड़ा सा,
नहीं
तो
बेटा,
फिर सर
इस केस में तो आपका इनिशियल और फाइनल लैटिट्यूड सेम है ना, तो उनका
सेम
मीन भी
रहेगा।
वही होगा।
13 for plain sailing normally.
लेटिट्यूड फॉर प्लेन सेलिंग, यस।
Right. In parallel sailing, the initial and final latitude are the same because you are moving on the same parallel. So the mean lat will also be same.
यस सर।
But when you go to plain sailing, where the initial and final position may be on different latitudes, in that case, you calculate the mean and use here.
ओके सर।
Okay, beta?
यस सर।
Okay, let's proceed ahead then. Now moving on to the second rum line sailing, that is the plain sailing. So how does the plain sailing gets its name? Now initially when the navigators started moving into the seas long time back in the history, when we started making boats and started venturing out into the sea, we were not having any high-tech instruments to find the courses and the distances. But in those times also, we had the knowledge of trigonometry. Trigonometry is basically the solution of a right-angled plane triangle. So we were aware of how you can calculate the sides, the angles of a right-angled plane triangle. And the sailors used this same knowledge, that is the knowledge of plane trigonometry. There is two branches in trigonometry. One is the plane trigonometry, another is the spherical trigonometry. Plane trigonometry is for calculating on plane surfaces. Spherical trigonometry is for calculating on the surface, curved surface of a sphere. The great circle sailing and composite sailing use the concept of spherical trigonometry. But as I was telling you, in the olden days when navigators ventured into the sea, they wanted to calculate these courses and distances, and they had the knowledge of trigonometry available with them. So what they did was they used the same trigonometry knowledge to calculate the courses and distances between two positions. So how did they do that? They basically made a right-angled triangle, a plane right-angled triangle involving the initial position and the final position, and they solved it using trigonometric ratios. So that's why the name given to this particular type of sailing was plain sailing. Now going into trigonometry, we are aware that there are three different ratios in trigonometry. We have the sine theta, which is equal to perpendicular upon hypotenuse of a right angle triangle. We have the second ratio as cos theta, which is equal to base upon hypotenuse. And we have the third ratio as tangent theta, which is equal to perpendicular upon base. All three referring to the plane right-angled triangle. So let us see now, how did we use these three trigonometric ratios, sine theta, cos theta, and tan theta, to calculate our courses and distances at sea. Let's assume that the vessel is right now at this particular position. You can see the position on the screen now. Let's mark it as A. This is our initial position or the starting position. Let's assume that the vessel wants to reach at this particular position displayed on the screen now. I'm highlighting it with my laser pointer. So this is our destination position. Let's mark it as B. This is our final position where we want to go. Now our main aim, we know what is our initial position. We know what is our destination. Our main aim here is to find out what course should we steer to arrive at our destination B? And the second thing, what distance should we be steaming to arrive at our destination? Distance is required because you need to fuel up basis that particular distance. You need to have the supplies, fresh water, provisions, food as per that. So these two are the important things which we want to find out. So how do we do that? We basically involve these two positions in making a right angle triangle. How do we make the triangle? Let's see. You can see a right angle triangle being made. Our initial position and final position are the two vertices of this right angle triangle. Now we want to approach our destination position B starting from A. So the arrow shows the direction in which we are proceeding. And this side of the triangle, that is AB side, is basically representing the distance which we need to cover to reach our destination. So this is one of the items which we are required to find out. Now let's name the third vertex of the triangle as C. Now this angle which you see here, this is angle A. This is the angle between true north. You see AC line is pointing towards true north. It's a vertical line, and the direction of true north on our chart is vertically upwards. So AC line represents the true north, and AB line represents the direction in which the ship's head is. So this is the angle between true north and the ship's head. This is basically our course. So let's mark this angle as course. This is the second item which we need to find out. Now, if you take your attention to the vertical side of this particular triangle, that is AC, Alpha Charlie, this vertical side of the triangle on a chart basically represents the difference of latitude, in short known as D-lat. This is the D-lat between our initial position A and our final position B. If you plot these two positions on the Mercator chart and you measure this up and down distance, that is Alpha to Charlie, it will give you measure it on the latitude scale, it will give you the D-lat, or it will be equal to the D-lat between the two positions. Now the horizontal side, which you see, the topmost side of the triangle, is the departure between A and B. So if you see on a Mercator chart, it is the east-west distance between these two positions, the starting position A and the destination position B. And this east-west distance between the two positions is known as departure between them. So we have the triangle labeled now. We know all the three sides. We know one of the angles. Now in this triangle, the angle C which you see, angle C highlighted on the diagram now, is a right angle. It's a 90-degree angle, as AC represents a vertical side, Bravo Charlie represents a horizontal side. So we have a right angle triangle here. Now considering this angle as our course, that is angle A as our course, the side AB of the triangle is the hypotenuse. Hypotenuse is the side opposite to the right angle. So side AB is the hypotenuse. Side Alpha to Charlie AC, which is connected with this angle, is the base as far as trigonometry is concerned. And the horizontal side, that is Bravo Charlie BC, is the perpendicular. So we have identified the three sides. Distance is the hypotenuse, D-lat is the base, and departure is the perpendicular. Now let us apply the three trigonometric ratios to this triangle. Let's first apply the ratio of cos theta. In this case, it will be cos cos. Now we know cos theta is equal to base upon hypotenuse. So cos of cos becomes the difference of latitude or the d lat, which is the base, upon distance, which is the hypotenuse. Now this ratio, trigonometric ratio of cos cos, gives us our first formula for plane sailing, and that formula is d lat equal to distance cos cos. We have just taken the distance to the left hand side. So on one side you have the d lat, on the other side you have distance cos cos. So this is the first important formula we have for plane sailing. D lat equal to distance cos cos. Now let's go to the second trigonometric ratio, that is sine theta. In this case, sine of cos, it is equal to perpendicular upon hypotenuse. So sine of cos is equal to departure, which is the perpendicular, upon hypotenuse, which is the distance. Now this ratio gives us the second formula for plane sailing, that is departure equal to distance sine cos. So this is the second important formula for plane sailing, departure equal to distance sine cos. Now let's go to the third trigonometric ratio, that is tangent theta. Now in this case it is tangent cos equal to perpendicular upon base. In our case the perpendicular is the departure and the base is the d lat. So tangent cos is equal to departure upon d lat. This is the third important formula which we have for plane sailing. So you see the three trigonometric ratios, cos theta, sine theta and tangent theta, gave us the three formula which we use for plane sailing. Now these three formulas help us to calculate the course and distance if we know our initial and final positions, the departure position as well as the destination. If it is known, we can easily calculate what is the course and what is the distance. Now it can also be used to find out the position arrived in case a certain course and distance is followed. Let us say we know that we started from position A, we were moving on a certain course, we have a certain distance. We can easily find out with this course and distance what is the position where we are going to arrive. So these are the two most basic simple calculations which can be easily done using these three formula. Now just to give you a lead, if you know the initial position, you know the course and you know the distance. If you apply the first formula, the course is known, the distance is known, you can get the d lat. If you apply this d lat to your initial latitude, you will immediately get the final latitude. Now, when you come to the second formula, we have the distance, we have the course. So when we put these values, we can easily calculate the departure. Now, once we have the departure, we can convert it to d long easily by using the parallel sailing formula, which we saw just a little while before. Departure is equal to d long into cos of m lat. So once you convert it into d long, apply it to the longitude of your initial position and you get the final longitude. So a two-step calculation to find the position arrived. In case both the positions are known to us, you can easily find out the course and distance also. If both positions are known, you can calculate the d lat. The d lat can be calculated. You can also calculate the d long, which can be converted into departure. With departure and d lat, you can apply the tan course formula and it will immediately give you the course being followed. Once the course is known, you can go to formula number 1. You can put the course here, you can put the d lat value here, and you can easily calculate what is the distance between the two positions. So that sums up the plain sailing. Important thing to note here is that the triangle which we have made, this particular triangle, is made for the northeast quadrant. For every different quadrant, we have a different triangle. I'll show you a little while later the triangles for other quadrants also. But this is the one which we use for northeast quadrant. You can see the vessel is moving on a northeasterly track. And important thing to remember here, the course which we use in any of the triangles is the quadrantal course. It will become clear to you when you see the other triangles also. So the course which we use or which we obtain from the formula will always be the quadrantal course, not the three-figure notation course. So beta, any doubt up to here? All refreshed in the mind?
Yes, sir.
Yes, sir, all okay.
Okay, beta. So these formulas are pretty simple and straightforward. If you want, you can just take a screenshot and keep them handy with you. We will require them not only in GC questions, but later on also when we do the celestial navigation questions.
Sir, we can use any formula na, for calculation. The sine, cos, or tan means whatever is data given to us, we can use any formula.
Yeah, that's right, beta. You can use any of the formula. सिर्फ एक restriction है, वो मैं अभी आपको बताता हूँ.
Okay, sir.
Okay, so shall we move ahead, beta?
Yes, sir.
Okay. Now, as I told you that we have different triangles for different quadrants. Let's see the triangle for other quadrants also. The triangle which we just now saw was this one, that is the triangle for northeast quadrant. This angle was the course, this side was the distance, horizontal side departure, and the vertical side was D-lat. Now, if the ship is moving on a southeasterly course, then the triangle which we follow is this one. This position represents our starting position. This position here represents our destination. This side, the hypotenuse, represents the distance. The vertical side is the D-lat, and the horizontal side at the bottom is the departure. Now, if you look at the course angle, which is this particular angle here, it becomes clear to you that the course which we should be using in this sailing is the quadrantal course. So you see the course or the angle is measured with reference to south direction. This is the angle between the south direction and the ship's head. So this is the quadrantal course, south so many degrees east. Similarly, for southwest quadrant, you see this is the particular triangle. This is our starting position. We are moving in a southwesterly direction. This is our destination position. The horizontal side is the departure, and the vertical side is the D-lat. And this particular angle is the quadrantal course, south so many degrees west. And this triangle which you see is the triangle for the northwest quadrant. This is our starting position. We are moving in a northwesterly direction. This is our destination. Then the horizontal side is the departure and the vertical side is the D-lat, this angle being the course. Again, quadrantal course, north so many degrees west. So these are the four different triangles which we use for calculation in plain sailing. Now, one important thing, you can say a limitation of the plain sailing is that this particular form of sailing, though it is very simple and easy using plain trigonometry, It can be used for distances which are less than 600 miles. Now, why is that so? The reason for this is that you see we have used plane trigonometry for calculating our courses and distances. When we are actually moving on the surface of Earth, we are not moving on a plane surface. We know the Earth is a sphere. So the surface of Earth is not a plane two-dimensional surface. The surface is a curved surface, a three-dimensional curved surface of the sphere. So when you use plane trigonometry on the curved surface, errors are bound to occur. So in these calculations, errors are bound to occur. However, till the time the distances are small, to be precise, when the distances are less than 600 miles, the errors which are introduced are so small that they can be easily neglected. The resolution, the error is not so great that it is going to affect our sailing, so it can be easily neglected. However, when the distance exceeds 600 miles, the errors become appreciable and we need to consider them. So this sailing is used only for distances less than 600 miles. So for our normal passage planning, when the distances involved are much lesser than 600 miles, we can easily use this plain sailing to calculate the courses and distances. However, when you are going on transocean passages and the distances exceed this amount, then in that case, the plain sailing should not be used. Either we should use the great circle sailing, or if you want to still do rhumb line sailing with distances greater than 600 miles, we should be using what we call as Mercator sailing. So that is the next form of sailing which we are going to see. So now we come to the third rhumb line sailing, that is the Mercator sailing. Why do we have another form of rhumb line sailing? We have already done that using the plain sailing. I already answered that question. That is because the plain sailing has a limitation. It has a restriction that it can be used only for 600 miles. More than 600 miles, using plane trigonometry on a curved surface, a three-dimensional curved surface of the Earth, introduces appreciable errors which are significant and cannot be neglected anymore. So we use Mercator sailing. Mercator sailing gives us accurate result irrespective of whether the distance is less than 600 miles or greater than 600 miles. Now the second question is, how do we do or solve the question using Mercator sailing? Now to understand it very simply, whenever we use trigonometry, solving a right angle triangle, we have to have the three sides of the triangle measured in the same units. If you are measuring hypotenuse in centimeters, the base and perpendicular should also be measured in centimeters. So that is the basic principle of trigonometry. We cannot change the units. We cannot measure one side in centimeters and another in inches. The ratios will not work. Sin theta, cos theta, tan theta are not going to work that way. So if you remember, in the plain sailing triangle, the units which we used were the latitude scale units. We used the latitude scale units. Let me show you here. Let's consider this is our initial position A. Let's consider this is our final position B. Let's make the plain sailing triangle. This is the plain sailing triangle which we used. The third vertex was named C. This particular angle was the course. This side, the hypotenuse, is the distance side. The vertical side, AC, is the D-lat. And the horizontal side on top, that is B to C, was the departure. Now, if you look carefully, distance is measured as minutes of latitude. 1 minute of latitude is equal to 1 nautical mile. So we measure this side in units of latitude. Coming on to the vertical side, AC, we measure it as D-lat. Now D-lat, or difference of latitude, is also measured in terms of latitude units. The D-lat between two places is the number of times 1 minute of latitude can be placed. The minutes of latitude between the two places, again measured on the latitude scale. The third side which we have was the departure. And you see, again, I told you departure is the actual east-west distance between any two positions. So all distances are measured on the latitude scale. So you see, we measured all the three sides of this triangle in latitude units. Now in Mercator sailing, a simple way to understand it is that we convert from latitude scale to longitude scale. We will measure the sides in the longitude scale. How do we do that? Let me show you the Mercator triangle now. The blue color triangle which you see, bigger than the red one, is the Mercator triangle. And in this triangle, let's name the vertices as D and E. Now the side DE which we have is the D long between our initial and final positions. So you see the D long is measured using the longitude scale or minutes of longitude. So we have not measured it as departure, we have measured the east-west stretch between our initial and final position in the longitude units as D long. Now coming on to the vertical side now becomes AE, alpha echo. Now this vertical side, how to measure this side in longitude units? It is measured as what we call DMP, difference of meridional parts. What is this DMP? As is clear from the name, it is the difference of meridional parts between A and B. Meridional part is nothing but 1 minute of longitude. 1 minute of longitude is also known as a meridional part. So measuring this side in DMP basically tells us how many minutes of longitude can be placed between A and B's latitudes. How many minutes of longitude can be placed between A and B? So this is the meaning of DMP, difference of meridional parts. How many minutes of longitude can be placed between the parallel of our initial position A and the parallel of our final position B? So you see we have measured the side AE, the vertical side, in longitude units. Now coming to the third side of the triangle. Now the third side was distance. Now there is no way that we can measure the distance in longitude scale because the units of distance are fixed. The distance is measured in nautical mile, and 1 nautical mile is fixed as 1 minute of latitude, 1852.3 meters. So there is no way we can measure the distance in longitude scale. So in Mercator sailing, the third side is left unnamed. We neither use this for any calculations, nor it is found out using the Mercator sailing formula. So the third side of the triangle, that is AD, alpha delta, which is the hypotenuse side, is not defined or not mentioned or not used, not calculated in the Mercator sailing triangle. Now, how do we use these two sides to get the accurate course and distance? Now for this, again, we use the trigonometric ratio. The ratio is tangent course. Now in this case, the tangent course will be perpendicular, which is the D long, divided by the base, which is the DMP. So you see the formula here. Tangent course equal to d long upon dmp. This is the only formula which we use in Mercator sailing, the only formula. Now, one question may arise in your mind that we have calculated the course. If we know the initial position, we know the final position, we can find out the d long between them. We can also find out the dmp between them. Now, at this moment, a doubt may be arising how to find the dmp. I will tell you a little later. So we can find the d long and dmp and the course can be obtained. What about the distance? As I said earlier, we have not defined the distance in this triangle, the bigger blue color triangle. So how do we calculate the distance? For calculating the distance, we go back to the plain sailing formula, that is d lat equal to distance cos course. So once the course is calculated using the Mercator formula, the course is input in the plain sailing formula here. We know the d lat between the two positions, initial and final latitude is known, and putting these two values, the distance can be calculated. So the plain sailing formula for d lat is used to calculate the distance. Now, one important thing here, as far as trigonometry is concerned, mathematical calculation is concerned, you could have used the departure formula also. Departure is equal to distance sine course. So you can put the value of departure, you can put the value of course, and the distance would be known. But we do not use that as far as navigation is concerned. Why don't we use that? Because departure as a quantity is not actually present on our chart. What is present on our chart is either the d lat or the d long. So principally, we do not use the departure formula for calculating the distance. So mathematically, that's correct. It will give you correct answers, but fundamentally, always use the the d lat formula for calculating the distance using Mercator sailing. Another doubt which could arise in your mind is that since we have used the plain sailing formula for calculating the distance, how do we attain the accuracy, the required accuracy in this case? Now the accuracy is obtained, you see, the course which has been used here has been calculated using the Mercator formula, not the plain sailing formula. So this course which we have calculated is a more accurate course. Once this is used in this formula, it gives you a more accurate distance. So the error in the course and distance is eliminated, which came because of using plain trigonometry. Another doubt which could arise in your mind is that in this form of sailing also, we have used a right angle triangle only, and we have used plain trigonometry here also. So how do we attain the accuracy? The accuracy is basically attained using these DMPs, difference of meridional part. The DMPs account for the curvature of the earth. So when you get the DMP, difference of meridional part, it accounts for the curvature of the earth and brings in the required accuracy. The second way you could understand it from the chart point of view is, you see on a Mercator chart, 1 minute of longitude is a fixed quantity. You go anywhere on the Mercator chart and you measure 1 minute of longitude, it is a fixed dimension, fixed length. The latitude is not so. Depending upon where you are, at the bottom of the chart or at the top of the chart, 1 minute of latitude or 1 degree of latitude will vary in distance. 1 minute of latitude keeps on becoming bigger and bigger as you go away from the equator toward the poles. So 1 minute of latitude is a variable unit on the Mercator chart, whereas 1 minute of longitude is a fixed unit on the Mercator chart. So when you convert to longitude units in Mercator sailing, that gives you the required accuracy. Now to find out how do we obtain the DMP. The DMP or difference of meridional part is obtained from the Norris table. We have a meridional part table mentioned in the Norris table, nautical tables, and it looks something like this. You have the meridional parts, the degrees are mentioned on top here. You can see the degrees mentioned from 30 to 39, and the minutes are mentioned on the sides vertically downwards, starting from 0 minutes to 59 minutes. So for any degree and minute of latitude, you can see the meridional parts for that particular latitude. So you can find out the meridional parts for your initial latitude and your final latitude. You can find out the difference between them, and that gives you the DMP, difference of meridional parts, to be used in the Mercator sailing. So this completes all the forms of rumbline sailing. We covered up parallel sailing, the simplest form of sailing with a single formula. Then we covered up the plane sailing using plane trigonometry and the units of latitude. And then in the end, we covered the Mercator sailing, again using a plane right angle triangle, plane trigonometry, but with the units of longitude. So all these three giving us the required courses and distances. We can calculate the course and distance between two positions. And if we know our starting position and we know the course and distance being steamed, we can easily obtain the position arrived. These are the two types of basic problems which can be solved with all these forms of sailings.
So beta, any doubts?
सर एग्जाम में ये नूरिस टेबल और ये अल्मनाक दोनों ले आना अलाउ है?
Beta, usually MMD people provide their own Norris table and the own almanacs. But I always recommend that कि आप अपना almanac और Norris table भी साथ में रखें. Sometimes there is a shortage, so in that case you can request them to use your own almanac and table. Only thing is make sure nothing is written inside them.
Yes, sir.
Okay.
Okay, sir.
Okay. Or beta, any more doubts?
सर ये प्लेन टेक्नोमेट्री में मतलब जो एक्चुअली सरफेस ऑफ द अर्थ इज कर्व सरफेस बट वी आर यूजिंग द प्लेन टेक्नोमेट्री सो सम एरर विल बी देयर बट इट इज नेग्लिजिबल है ना सर?
Right, beta. In plane sailing, the error is there because nothing is taking care of the curvature of Earth. So up to 600 miles, the error is small and can be neglected. But more than 600 miles, it becomes appreciable. But in Mercator sailing, the error doesn't occur because we have considered this DMP, meridional parts. Now these meridional parts, they take care of the curvature of the Earth. So the error doesn't arise.
Okay, sir.
So that's why the Mercator sailing is equally accurate for any distance, less than 600, greater than 600, it is accurate. And especially in the GC questions, composite questions where the distance is in thousands of miles, we use the Mercator sailing.
Thank you, sir.
Okay.